All right, guys, today looking at solving systems of linear equations. Basically, to understand what a system of linear equations is, or a system of equations in general, it's just two or more equations that share a solution. And so the idea is you're trying to figure out what that solution, that XY solution is. So I'm going to actually cover two different ways that we can do that. There are other methods besides these two, but these are the two that I prefer and have found to be generally the easiest and most successful. The first method we're going to look at is we're going to solve by graphing those two equations, and we'll look at that shortly. And then the other method that we're going to use is often commonly called the elimination method. And it's more of an algebraic solution. And so kind of jumping into the graphing piece, I've got up to the upper right-hand corner, you see in there in red and blue, I've got two equations. They're clearly linear equations. They're written in slope-intercept form. And so the idea behind solving these and finding the solution that they share by graphing is pretty straightforward. You're just going to get a coordinate grid like the one I have here. You're going to graph both of them, and you're going to look for that point of intersection. So starting with the one there in red, y equals x minus 1. The y-intercept is -1. Okay, and then the slope is an understood 1 that's being multiplied into the x. And so if we think about that as rise over run, that's up 1 and right 1. And so I'm going to use that to just create some points. By the way, if you are not proficient in graphing linear equations using the slope-intercept form that I'm doing, you can check out my video on how to do that. It's not real complicated, okay? So I gave myself several points there, and then I'm just going to go ahead and connect those and make my line. Now, obviously, we're looking at systems of linear equations, so these should all graph as straight lines. And so it's going to look like that right there. Now moving to my other equation, again, I'm going to do the same thing and graph it here on the same axis. My y-intercept is +2, so I'm going to plot that point. And then my slope is also 2, so it's going to be 2 over 1. So I'm going to count up 2 and right 1 for my y-intercept, and I'm going to repeat that process over and over again. And then to go the other direction, I can also count down 2 and left 1 to go ahead and place my points. And I'll do it just like that. Okay, and then as with the first one, I'm going to go ahead and connect my, my dots here with a line, just like that. Okay. And so now I have both of my graphs clearly graphed on here. And then what I'm looking for, again, is the point of intersection. The point where these two linear equations cross on a graph is their shared solution. And so as you can see, that exists right here. I've got that colored in black. And when we look, that is left -3 and down 4. So that point where they cross is -3, -4, and that is our solution to our system of equations. That would be a solution that both of them share. We could plug those into both equations, and they would give us true statements. So that's graphing. With the elimination method, its premise is pretty simple, but it's more of an algebraic approach. And so I'm going to give us two other equations that we're going to look at here for using the elimination method. The first one is just going to be x plus y equals 2. And then the second one is going to be -2x plus 3y is going to equal -9. Again, this is a system of linear equations. If you'll notice, these are not in slope-intercept form. They're actually in standard form. And so that is a little bit of a different thing. Now, I could convert these to slope-intercept form, graph them, and go through the process I did before. But sometimes it's just easier to use another method. And so what we're going to use here is the elimination method. And the steps to the elimination method kind of lay out like this. So my first step is going to be, I'm going to multiply or divide one of my equations by some value. Okay, and that value, the whole intention is that in a minute I'm going to combine these together, and I want either my x or my y to equal 0 when I combine them. So in a sense, I'm eliminating that variable. And so what I'm going to do is I'm going to multiply this top equation by 2. And of course I have to do that to the entire equation. And what that's going to do is going to create a new equation for me. And that new equation is part of this system. So 2 times x gives me 2x. 2 times y gives me 2y. And then 2 times 2 gives me 4. And so with that, I'm basically done with this equation now. I've converted it to something else, and now I'm focused on these two. Because my next step is going to be that I'm going to combine these equations. Combine the two equations. Okay? And so in combining them, negative 2x plus 2x is 0. Which this is the goal. This is the elimination in elimination method. This is exactly what we want to happen. 3y plus 2y gives me 5y. And then negative 9 plus 4 gives me negative 5. And the idea behind this sets up step 3. I can now solve for one of my variables. I just simply divide by 5 to get that y by itself. And y equals negative 1. Okay. Now this is big. This is a big deal because now I can plug in that y, that negative 1 that I found was equal to y, back into one of my equations, and I can plug it into any one of them. I'm actually going to plug it into this one right here, the one that I kind of scratched out, but the original one, that x plus y equals 2. I'm going to plug the negative 1 back into there. It's just a simple equation, and so x plus negative 1 in the place of y equals 2. And then in doing that, I get to step 5, which is to solve for my other variable. And so I simply add 1 to both sides. X equals 3. And so my final solution here is going to be, this is my x and y coordinate, so it's going to be 3, negative 1. Okay, and again, had I done this graphing, used the graphing method, they would have crossed at 3, negative 1, and so that would have worked out just as well. So this is a quick review of solving a system of linear equations using graphing or the elimination method.